So far in this unit, we've learned a bunch of derivative rules. This one is going to be our last major derivative rule. We're going to look at some derivative rules later in the third unit, derivatives of like logarithms and trig functions and stuff like that. But this is kind of the last main overarching derivative rule that we need. It's called chain rule. And it's basically for differentiating when there's a function inside of something else. So basically, I don't really use this definition, but we use the chant derivative of the outside times derivative of the inside. So I'll show you guys a couple examples, and then this will make sense as far as like what's the outside and what's the inside. So something like this, we have to apply chain rule because we need to differentiate between the derivative of 2x minus 5 to the exponent 9 and something like just x to the exponent 9. So you guys don't have to write this, but if I had the function g at x equals x to the exponent 9, what would you guys say g prime at x would be? 9x to the power 8. So that's kind of like the first part of the chain rule, is that when I'm differentiating f at x here, I do have to bring down the 9 like in power rule, and we have to subtract 1 from the exponent. Okay, but what about the 2x minus 5? That's like a bit of a problem, right? Because I haven't accounted for the derivative of that interior part. So that's where chain rule comes into play here. So just gonna erase this. So what we have to do is we actually have to multiply by the derivative of the inside of this function. And that's going to be the derivative of 2x minus 5. So we'll multiply by 2.
Oh, that's to the power of 9?
No. Okay, so it's just times the derivative of the interior of that function. Okay, so this is the derivative of the outside. Consider that the outside prime, and this is the derivative of the inside. Okay, and then I'm just going to multiply 2 times 9. So it'll be 18 times 2x minus 5 to the exponent 8. Okay, before we do this one, I'm just going to write this as a rational exponent. Any questions on the first one? Okay, so same process here. We're going to take the derivative of the outside, so just applying power rule here. We have to bring down the half and then subtract 1. So we'll get negative half there. And then I have to multiply by the derivative of that inside portion. So the derivative of x cubed plus x. So that will be 3x squared plus 1. Okay, I'm just going to clean this up a little bit. We have 3x squared plus 1 on top. I'm bringing down the thing with the negative exponent into the denominator. So this will be over 2x cubed plus x to the positive half. And then you can leave it there, or we can also write, we know any half as an exponent is just a root. So it's 2 root x cubed plus x. Okay, so again, this is derivative of the outside times derivative of the inside. Any questions so far? Okay, so you're going to start to see some other rules come into play here. We're going to use like product rule and quotient rule, and inside of those we're going to have to use some chain rule as well. So for this one, we're going to consider this to be the first and this to be the second, because we're looking at a product of two functions here. Okay, so when we apply product rule, it's derivative of the first, which will be 3, times the second, plus the first, times the derivative of the second. So the derivative of the second, we have to apply chain rule here. So we're going to do derivative of the outside, which is 2 times 1 minus x. We subtract 1 from the exponent, so we're just left with an exponent 1. And then we have to multiply by derivative of the inside. So the derivative of the inside function, which is 1 minus x, is just negative 1. Okay, so I'll just kind of mark this out for you guys. This is the derivative of the first times the second plus the first times the derivative of the second. So we're applying chain rule in that second part. A lot of times when we have to use chain rule inside of product rule and inside of quotient rule, we can simplify much more efficiently if we actually common factor. So you're always going to notice with chain rule that each of your terms will have kind of like a common bracket going on. So if we just simplify this, I'm going to simplify like one step and then we're going to common factor that common bracket. I'm going to do 3x times 2 times the negative 1 here. So we're going to get negative 6x in front. And then it's times 1 minus x. And then I'm just going to common factor. So you guys see that we have at least 1 minus x that we can take out from each term here. So I'm going to remove that from each term. And then we'll be left with 3 times 1 minus x. So I'm left with 1 of the 1 minus x's here. And then just minus 6x. Okay, this just makes it a little bit easier to factor, if possible. And then we'll just expand and simplify in this bracket. So 3 minus 3x minus 6x. Okay, and then I think we can also common factor like a 3 from here and probably a negative from both of these brackets to switch them around. So I'm going to common factor a negative 3 from this bracket and also a negative 1 from this bracket. So the signs will change in here. Or sorry, that will be minus 1. And the signs will also change in here, and I'm dividing out a 3. So x will be positive, and this will become negative, negative 1.
What happened between the red and the green?
So I was just common factoring, so we have a common bracket that I'm taking out from both terms. Okay, so this leaves us with 3 times x minus 1 times 3x minus 1. I could have kind of also common factored probably the like 3 at this point here as well, but I forgot to do that, so we did it down here, which is fine. Essay. So I took out a negative from this bracket because usually when we're factoring, we express it as like x plus something or x minus something. So when I took out a negative 1, these just switched signs. X became positive and 1 became negative. Okay, and I also took out a negative 3 from here. Okay, certainly if I really wanted to, I could write this as 3 and then just 1 minus, like I could write it like that. It's just more proper to write it in this format. But yeah, you could, I think this would also be fine. Okay, any other questions on any steps that I've done here? Grayston?
How did you from 3 minus 9 less than 2x minus 1?
So I took out a negative 3. So when I divide this by -3, I get 1 here, or -1 rather, and I get positive 3x here, and then I just swapped their positions. Okay, so really what I'm doing is I took out a -1 from each of those, and I took out a -3 from each of those. So I'm dividing the first bracket by -1 and the second bracket by -3 to common factor those out. Anything else? Okay, let's do the second one. Okay, so again, we have a first and we have a second here. If it's helpful for you, you can always find like the derivatives of each individual part off to the side, and then you can plug them in to product rule. So if it works better for you, you can just kind of think about it as like, what is the derivative of x squared plus 3 to the exponent 4? So if we find the first prime, this will be 4x squared plus 3 cubed times the derivative of the inside, which is 2x. So that will be your first prime, or derivative of the first. And then if you have your second here, essay, yeah?
So the first we're using for the product rule is the shape of the first bracket?
So inside product rule, we'll have to do like derivative of the first times the second plus the first times derivative of the second. And when I do derivative of the first, I have to use chain rule. Okay, so when I do the derivative of the second here, we'll get 3 times 4x minus 5 squared times derivative of the inside, which is 4. So if you wanted, you could actually clean these up maybe like ahead of time a little bit. It would be 8x times x squared plus 3 cubed, and 12 times 4x minus 5 squared. Okay, certainly you can also do this like inside when you do the product rule. I just think maybe sometimes it can be a little bit easier to do them ahead of time, and then you're just going to plug into your product rule here, right? So we're going to do first prime times the second plus the first times second prime, or derivative of the second. Okay, so just applying power rule here. Okay, so we've already found derivative of the first and derivative of the second here. So let's just plug it in. Okay, so derivative of the first, which we found above, times the second, plus the first, just as it is. Times derivative of the second, so multiplying by this guy here. Okay, and I guess we actually don't really need these extra brackets on the outsides of these. It's not really necessary. If you want them, you can put them in. Okay, ideally, guys, I don't want to FOIL this entire thing out and then figure out how to refactor this, right? So the most efficient way that we can do this is we can see what's common in this first set right here and what is common in the second set. Okay, so let's just look at the numbers first. What is common between 8x and 12? Okay, so we're going to take out a 4. What else is common in these brackets? So they each have x squareds plus 3s, and they each have 4x's minus 5s. What's the maximum I could take out from both of these? I can take out 3. Okay, so I can take out 3 of the x squared plus 3s, And what's the max I can take out of the 4x's minus 5's? I can take out 2 of them. Okay, so this is my common factor, and then I have to write what's left in the bracket after I do that. So if I take out a 4, if I divide out a 4 from 8x, I'm left with 2x there. I've taken out all of the x squared plus 3's in that term, and I've taken out 2 out of the 3 here, so I'm just left with 1 in that first term.
What about the 2? Because when you divide 8 by 4,
I get 2x, right?
oh,
Okay, out of 12, we took out 4, so we should be left with 3 from that. I took out 3 out of the x squared plus 3's, so I'm going to be left with 1 of them. And I took out 2 of the 4x minus 5, so this is now gone because I've removed that from the second term there. Any questions on that one? Yep.
Sometimes they change our definition of which one's F and which one's G. Is that like the last one would be F?
It doesn't really matter at this point. We're just simplifying the derivative of what h prime at x is.
We have it.
Yeah, we've already got the derivative. We're just simplifying it. Okay, so now all we need to do, this is already fully factored, which is great. I just need to expand and simplify inside here. So we're just going to bring in this and simplify inside that black bracket there. Okay, it looks more complex than it actually is. All we're doing is factoring what's common between the terms. Okay, so you'll get the hang of it if you practice it. Okay, and then just simplify in that bracket there. Sorry guys, I didn't realize that it's 11:47. Okay guys, so we're going to stop there for today, but I am going to ask you to do some of the work from today's worksheet.